All right, thanks for joining me today for this session. Hey, I know you. Nice to see you again, friendly face, go way back. I'm JT. I'm going to talk to you today about our experience at Embarcadero of working with CLANG and LLVM and some of the challenges and good things that came out of using it to bring a Windows solution to bear. Earlier, I think it was Tuesday now, it seems like so long ago. Lots of great sessions, I've been having a great time. I talked a lot about UI prototyping on multiple devices. This is what we're trying to do in Embarcadero. We're trying to solve the application developer challenge for developers to build applications with good performance using C++ across multiple platforms, trying to use a common API, not just for standard framework things like network services or I/O, but also for things like data access or things like user interface. Some of the things that C++ standard or STL or Boost, for that matter, don't necessarily provide common services for. So that's what we're trying to do. And a big part of that is, and what drives the engine behind all this, is good compilers and good language support. So a while back, well, I'll give you a little bit of a background when we get to it here in just a moment. But what we're going to talk about over the next hour, I'm going to give you help you understand what we were trying to do. What were our goals? First of all, in selecting CLANG LLVM as the architecture, the tooling that we wanted to use to achieve these goals. And then I'll give you an overview of the project itself. And we'll talk about what worked well, what didn't work well. I'll try to be as brutally honest as I can. A lot of self-reflection went on as I was putting this together, a lot of good input from the team as well. And then lessons learned and what we want to do going forward. So I tell you straight out that we're very pleased with what we've been able to achieve with CLANG and LLVM. And we think it's a wonderful tool chain. And kudos to the team that's been working on that and bringing it to the, making it available to people like myself and teams like us who are building application developer tools. So some of you were in my last talk. Just wanted to share a little bit about myself. I've been programming since I was a young guy. Parents brought home a VIC-20, had to learn how to use BASIC to do something with it, and that's kind of when I fell in love with programming. And tried to stay with the graphical systems until DOS came out, and that's when I learned C++, so that was okay. My first IDE was Turbo C++. How many else out there use Turbo C++? Yeah, so what was great about it was more than just a compiler, right? You got everything in one, you were super productive, it was all about minimizing that edit, compile, debug cycle. And you could just write more code, and man, wasn't it nice to have an integrated debugger. And it fit on a floppy. In fact, I was going to share with you that I borrowed my first copy from a friend. Yeah, exactly. No license checking back then. I ended up going to school at UCSC, which is the University of California in Santa Cruz. Which college? I was Stevenson. And it didn't really matter, but I wanted the nice open field for the graduation, which overlooked Monterey Bay. I actually didn't live on campus. But and I studied there graphics rendering. That was my thing. I mean, I did all the compiler theory and all that too, but it was all C++ and all about graphics. I really wanted to do game development for a living and build 3D engines. And I also learned, as I was going to school there, that Borland happened to be like right down the road. And I was like, shit, I'm gonna go work there. So that's what I did. I started in the support ranks, and it was an incredible place to learn, because you didn't learn how to code in support. What you learned how to do is debug other people's code. And man, what a valuable asset that turned out to be. So as I'm coding these days and writing bugs, I'm much better at figuring out what I'm doing wrong. But over the years, spent a lot of, worked mostly on the C++ team. And around 2000, I spent about 10 years at Borland and left to go work in the Valley at a bunch of different startups doing things like embedded Linux, worked at Research in Motion for a little while, and all of this was C type programming, so I was right at home. About 3 years ago, I ran into an old friend who had worked on these products at Borland. Turned out Embarcadero, which, how many people have heard of Embarcadero before this week? Okay, a few of you. Wow, really, that many? That's surprising. Embarcadero had bought the Borland tooling, bought the Borland developer products. And he was telling me that they had some grand plans and ideas and wanted to know if I was interested in helping out. So 3 years ago, I rejoined Embarcadero, and I'm not doing daily development. I'm running the business side of it now. So it's a little bit different view of the world. But I do like to stick my nose in the meetings and see what's going on and help the teams achieve what they're trying to achieve. 3 years ago, it was when we really made the decision to go with CLANG and LLVM. And since that time, we've delivered a 64-bit Windows compiler toolchain on CLANG. We've delivered a iOS toolchain, and we delivered an Android toolchain. And we're actively working on 32-bit Windows, and this has taken a lot longer than we'd like. So, going back to the game development thing a little bit, there was this wonderful publication for many years called Game Developer Magazine. Anybody here ever hear of it? Awesome. So it was pretty much free. You never had to buy it. They would just keep sending it to you. But in addition to some really great programming articles, they always had this section called the Postmortem, and it was big development teams building AAA games, and they basically were brutally honest about what went wrong in the project. And I always loved reading those articles because you got to appreciate that people learn from their mistakes. But they also talked about what went right, and that was really interesting to see too, because you can learn things about how to make how to make very complex software, because games are very complex, and bring it to market. I mean, ultimately, their job is to ship something, or it's a bunch of wasted effort. So that's my job too. My job is to help the developer team ship something, get it to market in time, market it, sell it, and keep those funds going so we can continue to invest. So, just a quick throwback to Turbo C++. The one thing I wanted to point out here was that Turbo C++ was more than just a C++ compiler. Can you guys still hear me? I should probably get a little closer. Turbo C++ was more than just a compiler. It was a development environment. It was a collection actually of a lot of tools that you may or may not have been aware of. A debugger, profiler, I mean, there was a lot going on there. And that's what we're doing as well in Embarcadero. We're not just shipping a compiler. We're building actually a pretty complex development environment trying to solve some very modern problems that application developers have. So the compiler is critical, of course. Without it, you're never going to get an app to run on a device or run on a platform. But all these other pieces are very important to delivering a good developer experience. And so Borland pretty much had invented the IDE, and from there, a lot of innovation went into trying to make developers more productive, whether it was in the framework or in the tooling or in the language itself. This is what the heritage of the people that are working on these tools today continue to take forward. So Borland, throughout the years, had been a big C++ company. Turbo C++ was incredibly popular. Borland C++ did pretty well too, until Visual C++ really just started to take off. And it was interesting because we had competing frameworks. So, people were getting framework religion. So we had OWL on the Borland side, we had MFC on the Microsoft side. But language compliance was always something that was important to C++ developers. So if a new standard came out, hey, we got to be able to use these new language features. Throughout the years, pardon me, Borland had written their own C++ toolchain. So one of the hallmarks of a Borland compiler, for those of you that remember, was that it was incredibly fast at building. And it took a lot of shortcuts to do that. So for example, there was no intermediate representation between the front end and the back end. They had, let's call it carnal knowledge of one another, which, over the years of trying to keep up with the standard also made the code base pretty brittle. And so that was the cost of having a fast compiler, was that you lost some flexibility. And you also ended up, especially over years, losing some of the architectural value of separating these aspects of the tool chain. But Borland continued trudging on, trying to address a lot of these new features over the years. And around the CodeGear time, this is probably more history than you may be aware of, CodeGear was a spin-out from Borland. Borland decided it wanted to be an ALM company, which was like, requirements management, testing, all that kind of stuff. And so they set the tools out on the side, which was the money-making business unit. And then Borland started, our customers, being C++ developers, also told us, hey, we really appreciate the productivity that we get, but we need to have good language compliance. We need to be able to write code that allows us to take advantage of these great new features. We also need to be able to write some portable code. And our compiler was falling behind, frankly. So started looking at different front ends. EDG was one that the team spent some time with. It was a great front end. It just didn't quite fit with the model. So it was abandoned. And like I say, about 3 years ago, when I came to Embarcadero, CLANG LLVM was pretty new, at least to beyond the Apple platform. And the team convinced me we should do this. And it was a great decision. I think it exceeded everybody's expectations in terms of how easy it was to really work with. Although there was a tremendous amount of effort in doing the things that we do to the language to enable the complete development environment, it was worth it, because the one thing that we could deliver and be sure that we can deliver also was good language compliance. And that's something that CLANG really, really delivers on. Plus LLVM is a great back end. One of the best optimizers out there, very clean intermediate representation. So this has been, I think, a very valuable experience. So as I mentioned, we deliver more than just tool chains. We actually deliver C++ and Object Pascal tool chains. Overall, we probably ship about, I would say, 10 distinct tool chains, maybe more. Tool chain including the front end and the back end, linkers, debuggers, assemblers, all the ancillary tool chain kind of stuff. But we also build an application platform. And our goal was to build cross-platform libraries that ran across the main desktop operating systems as well as the main mobile operating systems. Since we do 2 languages, we also share a common RTL. And this RTL is something that is shared between the Object Pascal and C++ side. You can still continue to use pure C and C++ RTL, but this is an additional RTL layer that's provided to developers using this product. And on top of that sits an application framework. So that's stuff like data access, collections and containers. Again, doesn't mean you can't use C++ containers and collections. Of course you can. This is just another set. Things like talking to cloud services, REST and JSON, middleware, user interface, which is one of the bigger challenges of building cross-platform apps today, especially with C++. So that's another, our team is probably in total about 200 people. And just to put it into context, about 1/5 of those are working on C++ compiler. So there's a lot of work. Half of those guys are QA too. So there's a lot of testing and stuff that needs to go on in a product this immense. I was sitting through the Microsoft Office talks the last couple of days. And again, that's another humongous product. And I could fully appreciate, it was great to see the architecture, but I know what's going on behind the scenes. It's just a tremendous amount of work to bring something like that to market, especially when it's on multiple operating systems. And then on top of this is a full-featured IDE. So code editors, build and project management, UI designers, changing platforms that you have to support and to run on as a host, integrated debugging. So these are all things that come together to deliver a product that we bring to market. So again, the compiler's critical link in the solution, but it's also just one link. There's about 10 other links that make up this total product. So with that context in mind, we needed to definitely find a project that we could leverage to deliver this ANSI compliance that we needed and that our customers were asking for. So that our compiler team could also focus on platform enablement. That's actually extremely costly, trying to move all this stuff from one platform to another. To support iOS and Android, even though there are C++ compilers on both for a C++ runtime environment, very challenging to get something to support all this runtime on each of these. So this is our vision. Today, you're working on one platform with one IDE, and you build one target platform app. And for each platform that you go to, you have to do this with different tools and different languages in some cases. And this is what we really want to try to push. one team, one language, multiple devices, multiple platforms. That kind of sets the stage, I think, for helping you understand what motivated us to do what we're doing. We also have actually what's the word I'm looking for? A large, but a developer base that goes back 15, 20 years in some cases, that have kept up and are still trying to maintain their code base as well, and we're trying to bring forward. So there was a lot of conflicting goals in what we were trying to do. We tried to help people build a modern application, but at the same time also help them do it in a way where they could leverage a lot of that code that they were using and continue to get the advantages of our development environment around the productivity with the IDE and the development environment and user interface design and integrated debugging and on and on and on.
So are you plugging your Pascal compiler in LLVM as well?
We do, actually, yes. And that's something that I'll be talking about in a little bit. So that was... They don't, really, because they don't think about that often, but yeah. So the question was, did we plug in our Object Pascal front end to LLVM? Yes, we did. And I'm going to talk about that because that's a great example of why LLVM is such a great project. Really easy for us to take our front end and do that. As I mentioned before, our tool chains were very intimate in terms of the front end and back end. And we were able to separate those and build to that IR. And it went actually rather fast. So this is what we're trying to do. Sorry, was there a question? Okay. So we're trying to build, let's call it a language engine for lack of a better term. Look at all the things we're trying to support. We're trying to support many different language standards, including compatibility with Borland C++ and C++ Builder. These are our existing products. And the standard language as well. So again, these are, in many cases, sometimes conflicting goals. As well as all the standard libraries that people use out there. Not the standard library, but Boost and Loki, Ace, those kinds of libraries that people need to use out there. Our development environment, I talked about this a little bit during the UI prototyping talk, encourages visual design. And in order to deliver that, there's actually extensions we made to C++ many eons ago because C++ didn't have the facilities at the time. Things like taking public members and making them publishable to the design surface. So we created a new container class called published. And a property was basically a public member that had getters and setters for reading and writing these values inside this object inspector. In fact, it was in 2002, we brought a paper to the committee suggesting some of these additions to the language. And I remember the committee wasn't keen on it because they said, who's going to write user interfaces in C++? Well, that was 14 years ago now. So, of course, the world has changed. We still think it's really a great way to write not just any app, but also client-side applications, which are heavy on user interface. And so we continued on with our extensions. There's actually not that many extensions. There's like 4 or 5. But they do a lot. And this is what the first part of moving to CLANG really was about. It was about writing these extensions that did things like allow classes or class definitions to include published members with properties. Also to do things like generate rich RTTI. And when I say rich RTTI, I mean more than just being able to cast and be told if it's a bad cast, but just, I try not to use an explicitive, a lot of information about that object so that it can be dynamically invoked, dynamically queried about what it can do. A lot of the framework utilizes this RTTI. So that was a lot of effort. In fact, it took about, it was a good 2 years in total effort to get all of our extensions and work into CLANG in the first place. And again, it's not a lot of extensions from the perspective of the developer who writes double underbar property, for example, was all the work that went into trying to get it to fit in to CLANG. And CLANG, for its sake, was actually pretty easy to get it into. It's just that this was a lot of code in the background that did a lot of things. One of the real goals for us, of course, was to be able to generate ARM code as well. We knew we wanted to get to mobile, and ARM was the platform. So This really led us to look at many choices, but CLANG LLVM was I think it was the obvious choice after looking at the pros and cons of various approaches. We certainly could have tried to continue to build our compiler out, and we could have gotten to a lot of this. Something would have suffered, though, and it probably would have been language compliance, which would have been really sad. I did not want that. I wanted to deliver the highest levels of language compliance and the benefits of the tooling as well. So there's the background. So our goals in bringing CLANG and LLVM, or adopting it, was first to deliver a 64-bit Windows toolchain. So at the time, CLANG was not thinking about Windows at all, or CLANG or LLVM projects. And this is something we decided to try to tackle. There's a couple reasons for this. One is it was highly requested from our developer base to build 64-bit apps. They were missing out on that. We were behind, frankly, in delivering that kind of support. The other reason was that there was a lot less complexity in going to 64-bit than 32-bit. 64-bit basically had a pretty straightforward standard in the sense of calling conventions and object formats and the kinds of things that you don't think about with a toolchain but will kill a project when you're trying to support all these things. And we're going through this right now with 32-bit. So this was a really good test bed for us to see if we can do this and make it work. As I mentioned, one of the key goals was to have to deliver C++ 11 and have a high level of language and library compliance. So that was a critical must-have feature in addition to generating 64-bit binaries. On top of that, we needed to support our frameworks, and that meant these common APIs in existing frameworks with existing conventions and language usage based on 15-year-old C++ technology, and bring those guys forward as well. And lastly, we needed something that gave us a flexible architecture to at least support various Intel platforms, which included 32-bit, 64-bit, but also ARM platforms. So we knew that right after finishing 64-bit, we were going to jump onto ARM platforms and try to build an iOS version and try to build an Android version as quickly as we could, because we felt like we were behind. There was already, in the mobile space, kind of an interesting thing going on at the time. At the time, there was a lot of apps being built with web technologies. Everybody was saying, we got to get mobile apps, we got to do it as quickly as possible, we can't build a separate app using Objective-C and a separate app using Java, so we're going to build using HTML and JavaScript. And almost everybody did this, especially from the enterprise side. And they actually were able to deliver applications. They're pretty simple applications for the most part, but they were able to deliver applications. And so that's what we were kind of fighting against. People didn't believe at the time in the value of native. Now, a couple things have happened since then. One, when they started delivering apps this way, users stopped using them because the user expectation on a mobile device was a lot different than in a browser. And the latency exposed by a JavaScript runtime was too much for the typical end user. They could tell. How many people are familiar with Facebook's experience in trying to do this? A few of you? It's a pretty famous story. I mean, these guys are the web developers in the world. They know HTML5, they know JavaScript better than anybody. I would think we would all agree that they write one of the most complex web apps there is. And they try to take that exact same source code and bring it to mobile, and they got an app running on mobile, but guess what? Nobody used it.
Everyone used it, but everyone complained about it.
Everybody wanted to use it, but yeah, it suffered.
They used it and they once started on the App Store, I think.
Well, I went to a talk at Facebook with the project manager, and she basically said their stats showed that people adopted it and then quickly stopped using it. And they said, this is not going to work. They rewrote their apps using Objective-C and Android. And it was kind of a new wave of people starting to appreciate the value of native applications again. Unfortunately, also during that time, the term native got kind of overused. In fact, people writing frameworks for web-based languages started calling their apps native because you could package it and sell it through an app store. So we're kind of dealing with that too. Ultimately, that's our biggest competition in terms of language adoption and usage in mobile. There's some people that do platform. I would call it platform as opposed to native, using Dalvik and Java, using Objective-C or now Swift, and Cocoa. There are, and then there's everybody else who's using web. And again, more and more people are trying to use platform or native solutions to get better performance. So this is what we went into a couple years ago, trying to solve. And thinking if we could solve this, we might be able to deliver a platform that could deliver the best of both worlds. There's this business benefit of having a shared source code base that something like HTML5 and JavaScript can deliver on. But the things you had to give up, performance in particular, device access was really hurting developers versus the expensive proposition of having to build in a bunch of different code bases for each platform. So this is really what we've been trying to achieve, and we're finally there. So specifically for this case study, we're going to talk about delivering the 64-bit Windows toolchain. Again, we wanted to make sure we could deliver a high level of C++11 compliance. Ultimately, the number one goal was that our developer base could build 64-bit binaries. But there were other must-haves. Language compliance was one of those. We wanted to have the best optimizer possible. We wanted to have compatibility with our existing frameworks and design methodologies and approaches. We have a lot of unique features in our product. Something you may not have heard of if you ever used it, called packages. Packages are basically shared libraries that do a little extra work so that you can manage objects in shared libraries much easier. That's the simplest way to describe it. But it's more than just your typical DLL or SO. And it turned out to be one of the big things that hit us when trying to move to LLVM, because LD just didn't have this kind of support at all. So these are the kinds of things that we're working on as we support these things. And we also needed a good debugger. I think we can all agree we write bugs. We need to be able to debug them. So debuggers are critical. I don't know about you, but it's a lot harder to do C out or C error to an Android phone than you might imagine. Okay, so let's get into the meat of the case study. We'll talk about what went well first. And I hope I do justice to the development team who couldn't be here. They're busy trying to get our 32-bit compiler out. We've had a lot of meetings on this. They've expressed a lot of opinions, some louder than others. Very passionate group. And so, like most developers, they always, I don't want to classify everybody, but they like to focus on what went wrong sometimes more than what went well. So this took a little teasing. But a lot of things went really well. One, we have a product on the market that delivers on all these goals. And I think that's a big win. So we'll start there. The first thing that the team noticed, that it was CLANG and LLVM, and I'll use those terms together even though we know they're separate projects, have a very clean architecture. There was concern about using a separate front end and back end because we knew there would be compile time effects, but it was a godsend, really, because it made our work much, much easier, much cleaner. Really extensible front end. All the component parts of a front end were well documented and well architected. It was easy for us to add keywords, for example, to the scanner and that kind of thing, and to extend the parser with our semantic information. It was well documented. Fairly well documented is how the team put it. It is an open source project. We all know how to use the source, Luke, but this actually had good comments and documentation to go along with it as well, which is helpful. The intermediate representation, yeah. That was actually something that we felt was very, how many? Repeat question. Oh, thank you. That's awesome. The question was, what do I mean by IR? That's the intermediate representation. So classical compiler theory, front end spits out intermediate representation, back end reads that, and generates CPU code. And 30 minutes left. Okay, great. And so you asked a question earlier, I'll repeat that question too. Did we take our Object Pascal compiler and go to LLVM? And the answer was yes. Once we discovered how well this project was architected, how well we could understand it and work with it, we decided to build, we were already building an ARM backend, by the way. I mean, pretty far down the line with it. We decided to try to bolt our front end onto LLVM, and it was surprisingly easy. Of course, that's all relevant, but it took us, I'd say, a few months to get it basically up and running, and things were working. I'd say that was pretty impressive because the backend we were working on was already a year into it and wasn't quite there yet. And the hard part was still coming up, writing a good optimizers for ARM. LLVM already had a good optimizer. So that was a big win. And it was actually a small team that moved that Object Pascal front end to LLVM. So that's just a testament to how well this project has been designed and architected and supported by the community. The second win was we needed to support Dinkumware. Dinkumware is our STL. We've gone through lots of STLs over the years. How many people remember RogueWave? That was one of the first ones we supported way back when. Nice. And several years ago, we went to Dinkumware because they just write a really good STL, especially for Windows. Problem is, they never really supported our compiler very well because we weren't a market leader compared to Visual Studio at the time, and also GCC, which is pretty much the de facto, or had been the de facto. I think CLANG LLVM has quickly overtaken it. So we based a port on the GCC branch. One of the things that really went well there was that CLANG had a really great switch compatibility with GCC. It made it pretty easy to start working with it and getting up and running. And
Why didn't you switch to the CLANG STL?
the question was, why didn't we switch to the CLANG STL? Because it didn't exist on Windows at the time. We could have, yeah. But we had a license with Dinkumware and Plogger, and he was interested in making this work too. We were also, again, one of our goals was to help people with existing code move forward as well. And STLs can have different support. They were already working with Dinkumware STL. We wanted to support them on the same STL. Of course, it looks like the CLANG STL is coming along very nicely too. That's something we can consider for future. And I'll talk about that actually in a moment. That's something that I think was a little challenging for us, actually. Backporting was something that we did quite a bit of, actually. Since we had to do a production tool chain that had a lot of other dependencies, we needed to settle on a version, and at the time it was 3.1. And there was lots of features that we needed or desired that weren't available in 3.1. Sometimes there were features that were in CLANG but not in LLVM that we needed to support the platform. So we started doing some backporting and picking pieces out of non-release builds to bring back. One example is when we went to Android, the 3.1 version of LLVM didn't support exception handling at all. There were some stubs there, but it actually didn't unwind or do anything. So we needed to backport that from a more recent version of LLVM. And that worked out pretty well. So that was something that's been great about this project, being open source, being able to see what's there, being able to have access to versions that are further out for backporting as needed. Here's one that may seem like a really odd one to you guys, but it was something that ended up being interesting for us and actually turned out to be a nice surprise. In our framework, we decided to support automatic reference counting in the framework in mobile. And this was mostly for the Object Pascal guys because they were asking for this memory management help. And of course, we didn't want to do a garbage collector. So we started looking at Arc as a good approach to do this. We went through a lot of ideas on how to do this. Of course, you can do automatic reference counting in C++ with just smart pointers and good practices. But it also would mean that code would have to change in terms of helping developers bring existing code over. Today, in their class definition, they would point to a pointer, or they would have a pointer to an object in the framework. So if we were to use a more standard C++ approach, we would have to ask them to change all their code, either in the declaration by wrapping it in a smart pointer, or in the implementation by how they access that pointer after they've implemented it. And so we started poking around a little bit, and someone had remembered that Objective-C had implemented some ARC. And then, of course, they used CLANG. So we did some tests, and it turned out we were able to access those hooks pretty easily. If it was built with ARC, we can create a little type that, rather than the standard new and delete operations, would call into these ARC add ref and release hooks. And surprisingly fast. Took us about 2 weeks to get that up and running. And so we were able to ARC enable the framework from a C++ developer perspective. So there are these kinds of features that are in the product, largely because Apple's had been using it to support Objective-C, and that we were able to take advantage of for a certain feature that's not really a C++ feature at all, but something that was important to our goals of enabling this memory management support in the framework and allowing the developers to continue to keep source code the way it is and not have to make big changes to their existing source code, some of which are millions of lines of code. So this isn't strictly related to the 64-bit project, but after we finished that project, and actually we started this work before we were finished with the 64-bit project, we started looking at the ARM backend and started doing a lot of things in parallel. And connecting to that backend was really smooth. There were things that made it a lot easier. We could also depend on one object format on the mobile platforms too. We decided to use the STLs that were provided by the platforms and not CLANG in this case, or to port Dinkumware, although we had a lot of discussions about that. And we used things like GDB server and some of these other ancillary toolchain items that are delivered by the platform. And so as I mentioned previously, some OS platforms were more ready than others. Android wasn't quite ready, at least at the time, with exception handling support, at least and also in the version that we were using at the time too. Question?
So your ARM support is 32-bit, not 64.
It's a 32-bit today, yes. So the question was, is the app 32-bit or 64-bit? It's 32-bit. So what went wrong? This is the fun one. There was a lot of challenges in this project. One is a lot of this early extension work we farmed out to people we knew who were no longer working for Borland that we'd worked with in the past, running their own company. This is, should have known, because all those game developer postmortems I read, typically contracting out work tended to be something that didn't go well. So nevertheless, we thought it was a good idea so we could work on some other things. We were still shipping products. These guys are excellent compiler developers, but just like in most contracts, we sometimes have missed expectations, different ideas on what means a complete project, testing, because they're not a QA team necessarily. So looking back on it, we probably should have taken the time out to do that work ourselves. And because it took a lot of time to integrate that knowledge back into the team. And someone was talking about tribal knowledge the other day. This was definitely one of those tribal knowledge kinds of things. Our guys are really up to speed now, but it took probably more effort than it would have otherwise if we had done this work in the first place. And this was with regard to the compiler extensions that I've been talking about, this front-end compiler work, and it took a really long time. In total, I'd say that part of the project, just to enable our extensions in the front end, was probably about 24 months to get it from partly through the contractors, back into the team, go through the testing process that we needed to get it basically production ready. So that was a long haul to not have a working compiler yet. The other thing that is really awesome about this project, but is really hard for us when we're trying to stabilize on a version, is that it's a really, really active open source project. Both are very active projects. Actually, every project that covered under LLVM is extremely active. This is awesome. But there's a lot of churn. And keeping up with daily changes is difficult. Not keeping up with changes after a week is almost deadly, or months. And so we're actually in a pretty tough situation right at the moment because we're not on trunk. We started moving to that model, but we're behind and we're feeling the pain. Let me tell you, we have basically 2 full-time engineers that are just trying to keep merges up and keep this up to speed. So this was a big, did not go well, big lesson, I think, for all of us. The other thing that can happen and does happen is you'll get competitive implementations that come in. Somebody got to it sooner. Maybe you've been working on it. They're going to win. And so you're going to end up not getting your version in there. You may end up not losing work or having to change work or having a fork.
So you're talking about checking your own changes back into Trump.
Yes. So it's 2 parts. One part's keeping up with it.
Yeah.
The other part is moving changes back in, absolutely. You got a question over here?
Yeah, well, my question was, more constantly, so
We hadn't been, frankly, and that's something that we need to change. And that's something that you'll hear in our, the question is, have we been contributing a lot of our changes? And we hadn't been, and it was a mistake. Something that is went in the not went well category, and something that we're going to talk about and going forward. Yeah.
How many of your changes related to supporting the Windows platform and therefore things you probably want in CLANG Trump?
A lot,
A lot.
frankly. And to be honest, we're seeing competitive implementations get in there now. So,
Who else is working on Windows?
yeah. Yep. There's a lot of history there. And there were things that prevented us from doing it that had nothing to do with technology that I'd be happy to share in a non-public forum with some people. Legal stuff, frankly, and that was imposed by ourselves, which was really unfortunate and frustrating. But we want to change that. So anyways, this is just good to recognize if you're working with open source in general, try to be as connected to that project as you can. If you're not contributing, at least build on that daily and do your merges when the changes happen. Otherwise, it's a world of hurt. The other thing that was challenging for us is all the other toolchain items. I mean, most people just think of a compiler as a front end and a back end, right? Well, that's true, but there's all sorts of other tools that go into making a binary and being able to debug that binary on the system. A lot of tools. And some of them are in various states of commercial readiness. Some of them we're taking more time to get to know and learn. LLDBs looks like a great project. We want to get there eventually. We're not there yet. We're still using GDB servers on the platforms. LLD is something we're really interested in and excited about, but it's not ready yet. We've had to use several different linkers. I mean, we basically have Frankenstein tool chains, and our guys are sitting in hex editors a lot, working on object format differences, calling convention differences, and all these kinds of other things that most of us don't ever want to think about when we're writing C++, right? How many of you out there work on a compiler? Okay, a lot of you. Well, then I was going to say, you probably don't have to deal with a lot of this pain, but those guys that do, yeah, this is kind of your daily life. And so we built a Frankenstein. We use, and one of the reasons we use our own linker on Windows is because we wanted to improve the build time. We have a good incremental linker technology. And so even though LOD wasn't ready, that was actually kind of a blessing in disguise because we ended up having to use our incremental linker, and that helped with regards to build times. Oh, question?
Do you expect people to contribute to LLD?
Yes, and LLDB, yes. Those are the ones we're going to start with because we have more opportunity to participate in those, and we have been actually in those projects. CLANG LLVM, we'll get back to that one.
So on the mobile platform, are you not using the native linkers with those platforms?
We are on the mobile platforms, yes, but we're not using native debug formats. So that's a whole nother topic, which is another what didn't go well. You know, that's coming up.
That's because of your extensions.
Partly, yeah. We also have always built very verbose debug info, and Dwarf didn't really have the capability to support that. Elf does a little better, but yeah, Dwarf on Windows, which is what we ended up using, didn't support all of our debug info. Question?
But instead of Dwarf, just use the ST.
Use which?
The AST.
Oh, actually we hadn't. That's an interesting thought.
That was Doug Greger's idea, and it's kind of implemented in Swift right now.
The question is, rather than debug format, use the AST directly. Well, part of the problem is that we do have to write it to a file that can be separate from the binary for debugging. Actually, now that I say that, that sounds like a really good idea. I'm going to look into that more. 15 minutes. Anyway, so quite a bit of Frankenstein work going on there, but lots of, I think, good progress on these other toolchain pieces and stuff that we definitely are involved in and want to get more involved in. Here's one that was kind of a surprise. Some language features don't come for free. Anybody believe that? I'll give you a simple example. We supported iOS pretty quickly in terms of getting to ARM. And I was writing some C++ 11 code, and I was just using the most basic C++ 11 feature, default initialization. Turns out that's not in the compiler at all. That's all of it's in the library, setting up constructors for all the different types. So if you're not using the correct STL, that feature is not going to work. Yeah. So we had naively used the STL that was on the Mac platform, not the one in Xcode. And so that one was behind, and we found out the hard way, thankfully pretty quickly though, that not all STLs are created equal. So that's a simple example, but those are kind of gotchas as you're going to other platforms and relying on existing libraries like that. This was one that we talked about already. Once we got it up and running, this is kind of, thankfully it wasn't a case of premature optimization. It was finding out after the fact, oh shoot, we got a real problem here. Our developers are used to really fast build times, and they were, I would say, at least, 5 times slower. And that was, is that the cost of flexibility and optimizations? To some degree, yes. And that's a reasonable argument to make. Although we're also trying to build an environment where people can quickly create apps for turning around. So like, for example, one of the things we try to do, since we have a common API, is you can build a lot of your app in Windows that will also work on iOS and Android. So we try to keep it local. A lot of the stuff we do actually runs inside the IDE in memory also. So these are all things that we try to do to minimize having to go through lengthy builds. And the build time, or the cycle of not just building, but also deploying and packaging and all the other stuff on mobile just adds so much more time to these daily cycles, or many times a day cycles. So that's something that we discovered, and we had to figure out a way to do it. And we decided at that point, okay, our incremental linkers definitely going to help here, and made it really work with that. But it turned out to be something that wasn't as big of a concern as we thought it would be. Most developers who experienced it were willing to exchange the build times for better language compliance and better optimizations. So that was good. We were worried about that, but it turned out to be a problem that wasn't as bad as we thought it would be. Okay, so some of the lessons learned from this. How am I doing on time? Okay. So one of them is that CLANG is very strict with regard to the standard. That's a good thing, right? Problem is, if you're bringing up a C++ code base that could be 20 years old, their developers are pretty crafty people. They're going to work around bugs. They're going to work around weird switches. They're going to do things that rely on what you present as the interface to the toolchain that probably shouldn't be done. I guess it's true of anything that you put out there that people can build upon. And they're going to find all sorts of corner cases and workarounds. And so one of our goals was to help our customers move forward. And I think one of the lessons there is, instead of just putting a new standard in front of them or new language implementation in front of them, you also got to help them move past a lot of these issues you don't necessarily think about, different types of switches and the impact it has, different looseness in the compilers in terms of language standard that maybe our old compiler was very forgiving about, and the new compiler is not, and for good reason. I was trying to think of one just the other day that hit us. It had to do with template initialization and two-pass, and CLANG did it correctly. We didn't in the past, even though it worked. Yeah, come on.
You could type in keyword and then type it in templates. Pass all your templates in one hit. You don't need to type it.
Right.
You pull out the system, and you get this two-phase name lookup.
Exactly. Good one. So lesson learned here is better documentation, better drivers. When I say driver, I mean things that set up things like the path, that also set up all the environment for building, so that they call our exe, but it does all the setup for them. So those are the kinds of things that we can help improve on.
What about refactoring tools? Because some of these workarounds sound like they're common patterns.
Question is about refactoring tools. Yeah, those are some ways to deal with it as well. Yep. I mean, in general, the customer base has been really good about adopting the standard and making these changes. And we were probably overthinking the goal to try to help keep them working with older conventions. So, you know, there's a lot of leverage there that people won't move up. When your business is around upgrading people, you want to make it as easy as possible too. And that's our business model. So that's something that we had to take into careful consideration. At the same time, a lot of these things that we really wrung our hands about, customers were willing to make those changes for better compliance, for example. So this ended up being a good thing. We could have done a better job of helping them though. I talked about that initial contract work. This is the second, I must have moved it. Yeah, this was a lesson learned too. We should have done this work in-house, basically, was a lesson learned. Or just had better project management, more check-ins, more frequent check-ins. Kind of the same lesson we learned around just working with an open source project in general too, be more connected to it. And this is kind of up to the next one. Keeping up is painful if you don't merge daily. This is probably the biggest one. When I said some of the feedback out loud, this was the biggest one, because the business in general was keeping our developer team from accomplishing this, and it was a mistake. And so, yeah, we're paying the price for it now, but that's something that, looking forward, we definitely want to change. We should have committed changes. We should have done it early. We should have done it often. And I think from us, we also want to pay more attention to all the other toolchain items. Again, LLDB, LLD. We're very actively working on these right now. We're not shipping them as production components, but we definitely want to spend time on them and support them and be more involved in the community and take these lessons learned forward. So looking forward, right now we're working on Win32 support. It's way more complicated than anything we've done. Structured exception handling is probably the biggest challenge, and that's something that I mentioned earlier was something we could have contributed back, but there was legal reasons that we created that kept us from doing this. So to make the long story short, it was a patent that expired, and so this is a good thing. Now we're all freed from the handcuffs of this implementation. There's lots of non-standard calling conventions. I guess you can call them standard if they're Win32, but there's lots of calling conventions. So this has been really challenging, and not to mention lots of object formats. We've never supported COF, because it's never been documented, and so we've always had our own object format. But each tool chain, for example, we're trying to mix Dwarf and OMF and trying to figure out all the right object formats to work to get our debug info, get everything working correctly. This has been a pretty complicated task. It's taken longer to do this, even with the front-end work, than it has taken us to get to ARM, for example. So this is actually something that's about ready to go into beta to our customers. So it's been a long time coming, but it was a lot of effort. And so for us on the CLANG and LLVM side in general, we're looking at taking it to more platforms. As I mentioned, our goal is to deliver a full application development environment that people can build C++ applications for that target multiple operating systems and devices. So Win32 is next. We do also build backend middleware software, so Linux 64 is definitely a next target today. Actually, yes, but we still have to do our work to that. Yep. The question isn't CLANG 64 already supported on Linux? And yeah, so this is a good head start. But other platforms could grow quickly. Android on Intel, and again, I think, and who knows really, WinRT, anyone? I don't know. Nevertheless, platforms are going to come up that we want to get to, and LLVM is definitely going to help us get there, but we also have to do our work on the CLANG side too. So we're finishing a 3.3 update, and you're going, well, 3.5 just came out. Yes, it did. And this is when I get back to the pain of not keeping up with the trunk. This is what it cost us. We're behind on it. And so it's getting better, but it was not ideal. And that was something that, again, has been a very painful lesson for the team. And we want to definitely explore strategies with the CLANG team from a business perspective in particular. How can we do more to share code back with the projects that we use and be more involved with the projects? Ultimately, what we'd like to do is we want to help promote C++ as meeting its potential for application development across multiple platforms. It hasn't really been considered a viable language for most for mobile development, largely because the platform vendors have chosen other languages, iOS with Objective-C and Google with Java, Dalvik, for example, although they both have very good C++ support. And so we, in building out the solution, we definitely want to be C++ advocates and evangelists on the client side in particular, on the mobile. To demonstrate more and more that C++ 11 is accessible to developers. We're at a C++ conference, so you guys are probably thinking, what's the big deal? C++ 11 is pretty easy to use. There's a lot of developers out there who are scared of C++ for reasons that are not necessarily logical. So we have to teach them. We have to inform them. We have to write articles about it. And that's a lot where we're spending our marketing effort is in educating developers. You don't have to live with HTML5 and JavaScript to get a common code base. You can do it with a real language like C++. And the way we're going to get them really to buy into it is what C++ is best at: great runtime performance and great facilities that are available to developers. Because the biggest competitor to it right now on these platforms is HTML5 and JavaScript, and who wants to live in that world?
Are you seeing any competition in Xamarin?
Oh yeah, Xamarin actually is, I think, doing quite well. They're definitely. Question is Xamarin a competitor? Definitely. They definitely put their bucket in C# as the language, which hey, there's a lot of C# developers out there, so they have definitely a market opportunity. But we want to definitely do this the same thing for C++.
But are you coming up against them when
Definitely, we come up against Xamarin. We come up against a bunch of JavaScript solutions like Coney and Accelerator. A lot of these are pretty easy to overcome depending on how well the developer's versed in developing with languages other than HTML5 and JavaScript. But absolutely, yeah, we run into Xamarin. We run into this is a pretty exciting time to be a developer tools vendor again. I mean, back in the 90s, it was crazy. There was lots of tools. Throughout the 2000s, there was almost nothing going on. And now it's like everybody wants to be a developer tools vendor again. There's probably 100 different choices for building mobile apps these days. It's crazy.
Who else is in the non-HTML5 space aside from you guys and Xamarin?
Qt would be an example, although they're primarily just focusing on the framework, which is largely what Xamarin's doing too, although they're building an IDE as well. The question was who else is competing in the space in the non-HTML? There's certainly a lot of scripting language solutions out there. A lot of them tend to be focused on like 2D casual game development or real app development. Yeah. It's funny that you say that, but those are the money makers on all these platforms. But you're right. Enterprises don't write in these languages, generally speaking. That's a good question. I think Xamarin's probably going to be the biggest competitor. But bigger than both than us and Xamarin is going to be HTML5 and JavaScript because it's still, especially by enterprises, seen as a very cost-effective way to solve their mobile challenges. And a lot of enterprises are driven by cost.
We have a different strategy.
What's that?
iPad only.
And that may be a viable strategy for some enterprises, but 85% of the world is on Android at this point.
Customers, so we don't care.
Anyways, I think we're towards the end. I just want to let you know that in pushing C++, we built a new product called AppMethod. It's basically our C++ builder, but we wanted to give it a new brand and get people who are looking at solutions, something new to think about, and really pushing C++ on this one. There is a free Android compiler that you can use for commercial development in it. That's sort of our seeding strategy. So if you want to play with CLANG LLVM on Android, it's more than just the compiler too. It's also the development environment and the framework, et cetera. But if you certainly have a compiler there at the ready that's CLANG LLVM for you to play with that you can get from the appmethod.com website.
So you can download the Windows CLANG LLVM.
Yeah, you basically get all the platforms in the first 30 days, and then the Android compiler continues to work for an annual renewable subscription. Okay, session is over. I just got the note. I could take a few questions though in the last before the next session. So if you have any, you can feel free to go to the mic there. Otherwise, you're welcome to leave to your next session. Thank you.